Okay, so my first set of directions are going to be to reduce through factoring. And we're going to start off super simple, 10y minus 20 over 25y minus 75. All right, clearly we can't, like traditional double set of parentheses, factor this, but we still can factor. What can we factor out of the numerator? Tejas? 5. Bigger than a 5 in the numerator. 10, good. We could factor out a 10. When we go through and we factor out a 10, we're going to have a y minus 2. And then in the denominator, can I factor out a 25? And we're going to be left with y minus 3, not 25. Y minus 3. All right, some mistakes I see repeatedly. I'm still seeing this in pre-calculus, which drives me crazy. Can you cross those out? No. If it were this, can you cross those out? Yeah. How come I can cross these out, but I can't cross the first set out? Hi?
Because of the parentheses, they group together. So it's not y, it's y minus 2.
Good, because it's not a y, it's the whole expression of y minus 2. So once you add a plus or minus sign in there, this is a huge concept that I feel like in retrospect, when I say it, you all know it, but then when you're caught up in the more difficult problems, I find that you guys are still making these silly mistakes of crossing things out that can't be. Unless you cross out, once you add a plus or minus, unless they're exactly the same expression with the same plus or minus and the same number after it, you cannot cross it out. You can't just cross out part of the expression. So this is y minus 2, y minus 3. Okay, on the 10 and the 25, because there's no plus or minus, right? There's no plus or minus between the 10 and the parentheses. There's no plus or minus between the 25 and the parentheses. It's just multiplication. Can I simplify the 10 and 25? Yeah, I can divide by 5. So then we are left with, 2 times the quantity of y minus 2 over 5 times the quantity of y minus 3. Now, this part is completely up to you. You can leave it like this. You can absolutely leave it like this. Or if you felt the need, you can distribute in the 2y minus 4 and the 5 to make it 5y minus 15. So Tejas, the way you were doing it in the beginning, only pulling out the 5 in the beginning, that's what you would have been left with. Oops, sorry. 2y, yep. And you can, I would accept either one of these, even though there is still a GCF that can be pulled out here and still a GCF that can be pulled out here, because nothing else will cancel, I will accept either one of these. All right, let's do another one. 3x squared minus 15x plus 18 over 5x squared minus 45. So we're factoring our top, we're factoring our bottom, we're sort of seeing what we're left with. So once we start factoring the numerator, before I make my double set of parentheses, what should I do? Before I make my double set of parentheses, what should I do? Michael? Yeah, what's the GCF here? 3. So now we're going to have x squared minus 5x plus 6. And in the denominator, can I pull out a GCF of 5? So then we're x squared minus 9. Can I keep factoring? Yes. In the numerator, that 3 stays there, but then when I factor, I'm going to get an x minus 6 and an x, not minus 6, sorry, minus 3. an x minus 3 and an x minus 2. And in my denominator, that's a dot, we have an x minus 3 and an x plus 3. Is there anything I can cancel? Yes. What, Philip?
X minus 3.
You got it. We can cancel out those x minus 3's. So now we are left with 3 times the quantity of x minus 2 over x plus 3. Can I, 5 times the quantity of x minus 3. Can I leave it like this? Yes. If you wanted to distribute it in, would I accept that still? Yes. Okay, so that's reducing, and I'm just doing super simple examples first, and then we'll step it up later. So that's just reducing. Now what we're going to talk about is multiplying. Okay.
Can you leave it as 3 parentheses x minus 2 over 5 parentheses x plus 3, or you have to like fully multiply it out?
So I said I'd accept either one. So either answer that you write, I would accept. Okay, multiplying's, I don't want to say fun, because really, is this fun? But it's better than others because there's so many different ways to simplify. So we can simplify each fraction like sort of vertically, right? So I can take 12 over 20 and I could say, okay, well, I can sort of reduce this fraction. What number goes into 12 and 20? 4. So we divide top and bottom by 4, and we're going to get 3 over 5. Then I can take 16 over 48, and what can I divide by? 16, yes, yep, you're right. So we're going to get 1/3. Now, I always start off by simplifying like each ratio by itself. But then when we have multiplication between the two fractions, you can cross simplify. Remember that? Multiplication is the only operation you are allowed to cross simplify through. So what I mean here is on the diagonal, I can say 3 goes into 3 once and 3 goes into 3 once. So now I'm left with 1 over 5 times 1 over 1. And then what do? We multiply across. 1 times 1 is 1. 1 times 5 is 5. (10c plus 15 over 10x minus 50 times x squared minus 25 over 6c plus 9. Okay, so I'm going to go and I'm going to try to simplify each fraction by itself. So in the numerator, I'm going to pull out a GCF of 5, and then I'm left with 2c plus 3. In the denominator, I'm going to pull out a GCF of 10, and I'm left with x minus 5. Going on to our second fraction. That's a dot, so I'm going to factor that x minus 5, x plus 5. And then what can I do in the second denominator? What should I do? Good. Pull out a GCF of 3, and I'm left with 2c plus 3. All right, to start, I'm going to now see what I can cancel out. Remember, we could cancel up and down, and how else can we cancel? diagonal, right? We can just cancel up, down, and diagonal. So I see diagonal right here. Doesn't 2c plus 3 and 2c plus 3, can't they cancel? I also see another x minus 5 and then an x minus 5. There's one more thing I can simplify down. Does anybody know? Tori. Good. We can simplify the 5 over 10. I could divide by 5, divide by 5. So now I'm left with 1 over 2 times x plus 5 over 3. Now we multiply across. 1 times x plus 5 is just x plus 5. 2 times 3 is 6. Okay, so I'm going to leave the 3x to the 8th by itself. I'm going to pull out a 5, so then we're left with 5 times the quantity of x plus 2. Second numerator, that's a dot, so we're x plus 2, x minus 2, and I'm going to leave the 6x cubed in the denominator. So now I'm going to try to cancel as much as I can. The x plus 2 and the x plus 2 cancels. Now I'm sort of in the second, I'm on the first numerator and the second denominator. Right here, let's focus on the x's first. X to the third goes into x to the 8th, right? What's x to the 8th divided by x to the third? X to the 5th. Is there anything left for x to the third, or did that cancel out? It canceled out because we divided by x to the third, right? But I can still do more here. What else can I do? Tejas?
Diagonally the 3 and the 6.
Good. Diagonally 3 and the 6. 3 goes into 3 one time. 3 goes into 6 twice. So now what am I left with? I'm left with x to the 5th over 5 times the, x minus 2 over 2. What do we do now? We just multiply across. So we have x to the 5th times the quantity of x minus 2 over 10. You can leave it like this or distribute in. Do I care? No. Okay, let's try this one. 2x squared minus 18 over 24 minus 6x times 2x squared minus 9x plus 4 over 3x squared plus 24x plus 45. All right, let's start factoring. So my first numerator, I'm pulling out a 2. Then we have x squared minus 9. My first denominator, I'm going to pull out a 6, so I'm left with 4 minus x. The second numerator, there's nothing to pull out, but I can factor this. When I factor this, I am going to get 2x minus 1 and an x minus 4. In my second denominator, I could pull out a 3, so we're x squared plus 8x plus 15. I'm not done because I can still factor more. I first have the dots, so we're x plus 3, x minus 3. And then my second denominator, I can factor that more. This is going to be an x plus 3 and x plus 5. Once I've factored everything, that's sort of when I start looking to cancel. Once I've factored everything, that's when I start looking to cancel. So I see that I can clear out the x plus 3's. Then I notice I have things that are almost similar, but not quite the same. Do you see how this is a 4 minus x and an x minus 4? They're so similar, but in this one, the x is negative, and in this one, the 4 is negative. Does anybody know what I can do to make them the same? Zoya? You can take out a negative. Doesn't matter which one you take out a negative from. No. What I'm going to do, because I always like to assign the negative to the numerator, I'm just going to pull out a negative here and then cross these out. It really does not matter which one you pull a negative from. I'm still not done, right? Can I simplify the 2 and the 6 down to 1/3? Can I cancel out this 3 and this 3? 3 on the bottom, 3 on the bottom. Can I cancel those out?
No.
Why not?
Well, why wouldn't you cancel them?
Because they're the same. Can I cancel them?
Wait, can you?
Philip, don't let me shake you. You were right. We cannot cancel these. Why can we not cancel these? Good, because they're both in the denominator. You were right. Don't let me shake you. Okay, so here we have x minus 3 over 3 times the negation of the quantity of 2x minus 1 over 3 times the quantity of x plus 5. So now there is nothing else to cancel. What we're going to do is we're just going to multiply these, but I'm not going to actually FOIL. So I'll pull the negative in front, and then I have the quantity of x minus 3 times the quantity of 2x minus 1 over, I can multiply the 3's though, right? 3 times 3 is 9 times the quantity of x plus 5. And you could leave it like this. If you wanted to FOIL and distribute, could you? Yes. Would that be a waste of your time? Yes. All right, let's talk about division. What are those special elementary words that go with dividing fractions? Quotient. Oh, that's a good elementary word. No, quotient is good. It's like the process. Tori? Yeah. Keep, change, flip. Remember that? Keep, change, flip. Keep. No, you guys never learned that. Keep, change, flip. When you're dividing, you keep the first fraction the same. You change division to multiplication and then flip to the reciprocal. So in high school, we just say multiply by the reciprocal. I like keep, change, flip. Okay, let's start off super baby. All right, so we have 1 over 2 divided by 2 over 3. What are we practicing? Keep the first fraction the same, change the division to multiplication, and then flip 2/3 to become 3/2.
could you simplify before you go to division, or do you have to like?
So you can simplify fractions. So you can simplify 1 over 2 and you can simplify 2 over 3. You cannot cross simplify because you're only allowed to cross simplify with what operation? Multiplication, and this is still division right now. So now let's keep going. So now we did our keep, change, flip. At this point, can I cross simplify anything? Can I simplify any fractions? No. So what am I going to do? Just multiply across. So 1 times 3 is 3, 2 times 2 is 4. All right, another way you can see this that you probably haven't seen before. Stacking. We don't get intimidated by how this looks. What does the fraction bar represent? What operation? Division. Fraction bar represents division. So what is this telling us? 2/5 divided by what? 1/3. Not 1/3. It's just 3. Yeah, so this is 2/5 divided, right? 2/5 fraction bar 3. So this is 2/5 divided by 3. But what are we going to do? We're going to change this into 2/5 times what? 1/3. I cannot simplify anything, so we just multiply across. 2 times 1 is 2. 5 times 3 is 15. Okay, you guys try this one. Actually, I don't want you to try this one. I'm sorry. Don't be mad. It's why we have erasers. I mean, what is basic math 101? Always use a pencil. All right, you guys are doing this one on your own. Are we ready? Maybe? Somebody tell me, what did we get? Nobody? James, come on.
What?
You got this. Max thinks you got this. Tell me what'd you get.
3 times 2n plus 3 and 4a cubed times n plus 3.
How many people got that? But yet nobody wanted to tell me the answer? Yes. Anybody need to see me do it? All right, let's do this. So, before we do the keep, well, I mean, does it really matter? Doesn't matter. You could have done the keep, change, flip first. If you did the keep, change, flip first, you end up with this. Now I will go to factor. So now when we go to factor 2n to the third plus 3n minus 9, you are going to end up with 2n plus 3 and, 2n minus 3.
So that's where I hung up because I wrote the 9 as a 4.
Oh, there we go. So I don't need to keep going. Does anybody want me to keep going? No? Sure. Okay then, forget that. All right, so now let's talk about undefined rational expressions. Okay, so simplify, then state restriction if needed. What does that mean? That means, let's say I have an expression of 5 over x minus 3. First question for you, can I simplify this? I can't simplify this, but right now we have a variable in the denominator, meaning we don't really know what that denominator is. So x could really be any number, but there is a value for x that would make this fraction undefined. When is a fraction undefined? Or when is something undefined? Michael? Good. When there's a 0 in the denominator, it is undefined. So what we want to do is we want to be cognitive to say, okay, well, this is completely simplified, but we know if x is equal to 3, won't the denominator equal 0? So we're going to say x cannot equal 3. That is the restriction. X cannot equal 3. So here we have 6a over, let's do this. A plus 2 over a squared minus 4. So my rule is saying simplify, then state the restriction. So what do I have to do first? Good. We need to simplify this, so we need to factor. So we're going to have an a plus 2 and an a minus 2. But what happens? If we're simplifying first, don't the a's plus 2's cancel? So now I'm left with 1 over a minus 2. So now after I simplified, what is my restriction? A cannot equal 2. You got it. Okay, are we ready to step up and see some problems that are a little bit more difficult? Maybe. Okay, so I'm going to do, this is number 4 from worksheet number 2. So this is worksheet number 2. This is number 4. We do not get intimidated by how things look. We do not get intimidated by how things look. We know the rules. We know what we're doing. So we just take it one step at a time. So write it down and then we will do this problem. Are we ready? Okay. So first thing that's catching my eye, there's so many things that are catching my eye, but the first thing that's catching my eye is this whole expression raised to the negative first power. I don't want negative exponents. So how do I fix that when the whole parenthesis is raised to the negative first power? We just flip what's inside, right? So this is going to be times 2x minus 1 over 5 minus x. Are we all good with that? Okay, and then sort of simultaneously, I want to put this top one in descending order, but then I'm also going to do keep, change, flip. So are we all okay if I do that all at the same time? So this is going to be 2x squared minus 3x plus 15 over 4x squared minus 9. So keep, change, and then flip. All right, now before I even start factoring or doing anything, I don't know, something's really standing out to me here. Is anything, does anything stand out to you, Philip?
If we multiply either 1 minus 2x or 2x minus 1 by negative 1, we can cancel out.
Look, can't we essentially cancel out that whole fraction right there? So we have 2x plus 1, but then we have a 2x plus 1, but then a 1 minus, oh wait, this doesn't cancel. What am I saying? Because if I pull this out, this would be 2, sorry, that one doesn't cancel. Forget that. But which ones will eventually cancel? These two will eventually cancel. Sorry, never mind. We'll save that for later. All right, let's go back to the first fraction bar. What should we do with that numerator? What do you think I'm going to tell you to do? Factor it. We're going to factor this. If you factor this, you're going to get a 2x minus 3 and an x minus 5. Yep. And then we are going to get a, nope, this is a dot, 2x, what happened, Max?
The 2x minus 3 and x minus 5.
Oh, that doesn't work. That does not work. I'm sorry. What happened there? Did I write this wrong? That would not have worked.
It was 2x squared minus 13x.
Yeah, this is supposed to have a 1 here. There we go. Sorry. Can we fix this now? Now does it work?
Yeah.
So then what did I say? X minus 5. Does this work better now? Yeah, I didn't write down my 1. Sorry. Okay, and in the denominator, we're 2x plus 3 at 2x minus 3. Two x plus 1 over 1 minus 2x and 2x minus 1 over 5 minus x. What's wrong, Philip? The 1 for the 13?
I was trying to figure out what I meant.
We didn't do much. We just factored the first fraction. Are you okay?
Yeah.
Okay, can I start simplifying? So over here, I noticed the 2x minus 3 and the 2x minus 3. We can cancel those out. then something is catching my eye here. I have an x minus 5, but then I have a 5 minus x over here. Any ideas on that? What can I do? Kai, pull out a negative. So I'm going to put that negative right there, and then can I cancel out the x minus 5s? All right, what else should I do? What else should I do?
Pull out a negative from 1 minus 2x.
You got it. Right over here, let's make this green, here and here. We can cancel those if I pull out another negative. So we're going to pull out another negative here. And when I pull that out, we are going to be able to cancel those out. Is there anything else to cancel? No. So now in my numerator, I have a negative times a negative, which is a positive. So do I have to write a positive? No. So we're just left with 2x plus 1 in my numerator. In the denominator, what am I left with? 2x plus 3. We don't need these parentheses. Can I do this? Good. Why no? Why can't I do that? Good. They're not products. They're attached through addition signs. All right, ready for me to make it a little harder? Is that funny? If Philip's funny because he's stressed? Okay, this is number 6 from the worksheet.
Why aren't the negatives we pulled out? No, it's not
Negative times negative 1 times negative 1 is a positive 1. Don't be scared, Philip. Or be a little scared. All right, this is number 6 from worksheet number 2. Welcome to Algebra 2. You don't think you're coming back?
It's okay, so I have faith in you.
You got this. Okay. So this looks pretty intimidating, but the first thing I'm noticing, or the first thing I want to point out to you is multiplication, 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 right? Minus sign. Multiplication, multiplication, multiplication. So how am I going to treat this? I'm sort of going to treat this like a binomial. Why am I treating this like a binomial? Because there's only that one subtraction sign and then it's all multiplication. Something else I'm noticing. I'm looking inside my parentheses. T squared minus 2, t squared plus 5. T squared minus 2, t squared plus 5. Doesn't it seem like the same things within the parentheses? So I'm thinking, you know what? So this doesn't look so overwhelming to me. I'm going to use substitution. I'm going to let Philip.
I have a question. So kind of like we can do, I don't know, like 2x plus 3x. If we just make t squared minus 2 squared, oh wait, we can't do that.
They're not the same. I see where you were going, and you would have been able to do that if they were the same. All right, so I'm going to, do you guys like A and B or X and Y better? X and Y. Okay, so I'm going to let X equal 2 squared, t squared minus 2. And I'm going to let Y equal t squared plus 5. Are we okay so far? All right, so now what do I have? Based on that, I'm going to have a 3x squared y minus a 2xy squared all over what did I say? X times t minus 4 squared. quantity of t minus 4 squared. Okay, are we ready? Is everybody okay how I went from this to this? Because this looks a lot less intimidating. Do you agree? Looks a lot less intimidating. Okay, so now, what do you think I'm going to tell you to do in the numerator?
GCF.
Good. We're going to pull out a GCF of what? XY. So I'm going to pull out an X, I'm going to pull out a Y. When I pull out an XY, I'm left with 3X minus 2Y all over X times the quantity of t minus 4 squared. Okay, let's keep going now. What can I do?
You can like divide by X.
Yep, we can cancel out those X's. Okay, so now we are left with y times 3x minus 2y over where is this? T minus 4 squared. Are we okay so far? Okay, so now what I'm going to do, I've simplified in this version as much as we can. Do you agree? So now what I'm going to do is I'm going to substitute back in. When I substitute back in, I don't remember what we say was y, t squared plus 5. We're going to have a t squared plus 5 times, now there's going to be a lot going on inside these parentheses, a 3 times, what was x? T squared minus 2 minus 2 times t squared plus 5. All over t minus 4 squared. We cannot leave it like this. We're going to have to do a little bit more work. So what am I going to do now? I'm going to distribute in this 3, and I'm going to distribute in this negative 2. So now in my numerator, we are t squared plus 5, and then 3t squared minus 6 minus 2t squared minus 10. We're going to keep going inside those parentheses and simplify more. So I have a 3t squared and a negative 2t squared. I have a negative 6 and a negative 10. And we're going to end up with t squared minus 16. Everybody still okay? I am not done. Why? Why am I not done, even though we feel like we should be done because our brains hurt? Tori? There's a dot. And if this was a dot and nothing would cancel, I wouldn't have to factor it. But if I factor this dot, will something cancel?
Yes.
Yeah, a t minus 4 will cancel. So right now, because it will cancel, so if you have the foresight and you could look ahead and be like, listen, if I factor that, I know nothing's going to cancel. You do not have to factor it. If you don't know, then factor it and see. But if you have the insight to know that nothing will cancel, you don't have to cancel it. But if something will cancel, you do have to factor it. So what happens here? I can cancel out this t minus 4 with one of these t minus 4s, right? So now we're left with t squared plus 5 times the quantity of t plus 4 all over t minus 4. Hi.
Let's say, for example, bottom was like t minus 3. Would you still have to simplify?
No. So if you knew that if you factored it, nothing would cancel, you do not have to factor it. Do we have time for another one? Probably not. Call it a day. So I anticipate there to be a lot of questions on the homework.